Go.
So now let's talk about Ohm's law. So what is the formula on getting Ohm's law? V is equals to positive, negative I R. Why is it positive, negative? You can see in this illustration. The current is entering a positive terminal. So we will use V is equals to positive IR. So let's try to solve it. The volts is positive because it enters a positive terminal. So let's try V is equals to negative IR. You can see this illustration. The current is entering a negative terminal. So we will use V is equals to negative Y times 2. So V is equals to negative 2 volts.
Good day. I will discuss Kirchhoff's current. First, I will define Kirchhoff's current. Kirchhoff's current law is the algebraic sum of the current entering a node is equals to the algebraic sum leaving the node. Then I will get the current here. By Ohm's law, we can get the derived equation plus R I. Then voltage here is 6 divided by 3 equals to 4. Then I is equals to now by the I here is plus 10 minus 9x. Then x equals again by Ohm's law. Vx equals to positive or negative. Then the current, the resistor here is 4 and the current is 12. And that is Kirchhoff's current. 1, 2, 3, go.
Solving this, we can get the equation of negative 5 plus 2i plus 6i plus 7i is equal to 0. You can get 15i is equal to 5 divided by 3. I is equal to 1/3 ampere. Vx here, using Ohm's law, Vx is equal to 2I. Substituting I, Vx is equal to 2 times 1/3 is equal to 2/3 volts. Vy is equal to 6I is equal to 6 times 1/3 is equal to 2 volts. Vz is equal to 7I. Vz, substituting I, Vz is equal to 7 times 1/3. Vz is equal to 7/3 volts. Please.
Good afternoon. Today I am going to discuss nodal analysis and how to find the voltage of the current using nodal analysis. So first let us define what is nodal analysis. So nodal analysis is used to determine the voltage in the node the voltage at each node relative to the reference node. So as an example of a circuit, I have here a circuit. So it has 49 ohms and 80 ohms and 24 ohms as its resistors. And then it has two voltage sources, 12 volts and 6 volts. And I have here two nodes, which is VA and VB. And since VB is connected to the ground, therefore VB's voltage is equal to 0. Next, I have here three currents, I1, current 1, current 2, and the current 3. So, in order to find the voltage of VA, we have to determine the voltage of this node. So, VA, the voltage of VA is, we have to first to use, we need first to use KCL. So, from node VA, use KCL or Kirchhoff's current law. And Kirchhoff's current law is the fundamental law from the conservation of the charges. So we need first to determine the sign of the current. So since I1 is going into this node, so therefore the sign of I1 is positive. And I2 and I3, since they are going out from this node, therefore the sign of I2 and I3 is negative. So now we can now equate the equation. We can now equate the current. So the algebraic sum of the current must be equal to 0. So we learned that I1 is going into the node, so therefore it is positive, and I2 and I3 goes out from the node, therefore it is negative. We have to solve for I1. So I1 is equals to I2 plus I3. So we have transposed these two to the other side. So since we don't have any voltage here, so just save this as equation 1. Then using Ohm's law, which is voltage is equals to positive and negative IR. So since we are solving for I1 or for I, therefore I conclude that it should be equal to I is equals to V over R. So the voltage is equals to 12 minus VA over 49. So how did I get this 12 minus VA? How did I get that? So I have here Vs, or the voltage source, is equals to VA plus VB, and since VB is equals to 0, therefore I have this only 2. So the remaining would be 12 minus VA is equals to 0. So this is the voltage from the reference node. This is the voltage of I1. So here the voltage is equals to 12 minus VA over 49. Next is to solve for I2. Since I2 is passing through this resistor, which has 24 ohms and voltage of 0, therefore the only remaining voltage in this wire is VA. Therefore VA over 24 is the current that goes or that flows to this wire. Next, we have to solve for I3. So I3 is equals to VA minus V6 over 80. So again, from VS equals to VA plus VV, I have here VA minus 6 as the voltage. And now since we have all these equations, we can now solve for VA. But before that, let us equate equations and solve for VA. So from I1 is equals to I2 plus I3, we have to substitute the value of I1 that we have solved earlier. So the value of I1 earlier is 12 minus VA over 20 over 49. So that is I1. And the I2 is equals to VA over 24, and VA minus 6 over 80 is the value of I3. So we need to, since we have equated these three and they have similar constants, so we have to first find the LCD of the denominators. So the LCD is equals to 1920. 1920 divided by 80, the remaining factor would be 49 times 24. So I have here 24 times 49 times VA minus 6 times quantity of VA minus 6. So that is from this equation. So 1920 divided by 24. So the remaining factor would be 49 and 80. So 49 times 80 times VA. So this is what I have acquired. And next, 1920 divided by 49. So the remaining factor would be 24 times 80 times the quantity of 12 minus VA. So 80 times 24 times 12 is equals to 23,040. And then substitute the value 1920 over 49. Sorry, I've mistake that. So, ayan. So, 80 times 24 is equals to 1920 VA over 24 pala. Over 24. So, over 24 VA. And next is 49 times 80 is equals to 3,920 VA, and then 24 times 49 is equals to 1,176. So times the quantity of VA minus 6. So remain, and then 1,176 times VA, so 1,176 VA times 1,176 times 6 is equals to 7,056. So next, we have to calculate for VA. So we have to transpose values with VA from this side and constant values from that side. So 23,040 plus 7,056 is, so 23,040 plus 7,056 is equals to 30,096, and 3,920 plus, this should 1,176. Oh, this should be equal to 1,920 over 24. So this should be 1,920 over 24. So the sum of all of these with VA is equals to 7,016. So dividing 7,016 both sides of the equation, we acquire VA is equals to 4.29 volts. So there we have VA, we have computed VA, which is equals to 4.29 volts. Next, we have to solve for the current. So we have to substitute the value of these to these VAs. So in substitution, we have I1, which is equals to 12 minus 4.29 all over 49. 12 minus 4.29 all over 49. We acquire current 1 is equals to 0.157 amperes. So 0.157 amperes. Next is for I2. Substitute the value of this AV to this, and therefore we acquire 4.29 over 24. We have I2 is equals to 0.18 amperes. Next is for I3. So VA minus 6, substitute the value of VA, therefore we acquire 4.29 minus 6 all over 80. We have negative 0.021 amperes for I3. So that's how you get voltage from the current or from the node using nodal analysis. And also we have acquired the current in the circuits. So I hope you have learned something from me. Thank you.
Mesh analysis. Mesh analysis provides another procedure for analyzing circuits using mesh current as the circuit spine. So, in nodal analysis, we apply KCL to find unknown voltage. And in mesh analysis, we apply KVL to find the unknown current. So, in a mesh, we need a loop which does not contain any other loop. For example, this loop and this. So, this is an example for problem for mesh analysis. So first, we assign mesh current. So, this is the, assign this as current 1, then this is current 2. And in this loop, we put this assign current 1, and this is current 2. So, this is the mesh current. And next, we assign arbitrary volts in the resistors. After we assign, now we will solve for the voltage of each resistor. So we apply KVL. So KVL in loop 1.
So this is our equation 1. So then next we apply KVL on the next loop. So this is the negative 8 volts. Minus 3 times I1 minus I2 plus 2 times I2 equal to 0. So we simplify. And now we get the equation number, our equation number. So now we will find I1 and I2. First we use by elimination. So I1 minus I2 equal to 8. And 11 I1 minus 3I2 is equal to 14. We times negative 3. So here we go 9 I1 plus 3I2 is equal to negative 24. Cancel this and 20 minus 1 is equal to, then this will become 16. So I1 is equal to 16 over 20 or 4 over 5. So now we get the I1. So to get the I2, we need to get the I2, we just need to copy the I1 and put in the equation 1. So substitute 11 times 4 over 5 minus 3 I2 is equal to 40. So, 44 over 5 minus 3 I2 is equal to 40. And we multiply by 5. So, 44 minus 15 I2 equal to 200. Then negative 15 I2 is equal to 200 minus 44. So negative 15 I2 is equal to 166. All over 50. So I2 is equal to 52. 5. Now we will get the Vx. So, Vx is equal to 3 I1 minus I2. So, Vx is equal to 3. I1 is 4 over 5. And I2 is 52. Vx is equal to 168 over 5 volts. So that's it. That is how to get the voltage by using mesh analysis. Thank you for listening.